Hello class, in this lecture I will be talking about hypothesis testing using t-statistic. I will be discussing one-tail problems in this lecture, and then I will solve Hawk's learning problems. So the first thing is, when do you use t-statistic? Again, this is when your population standard deviation is unknown and your sample size n is less than 30. So I will try to solve a problem and see if we can understand one-tail t-statistic. So the problem is a president of a university claims that the weight of the students in the university is at least 160 pounds. So this means when they say at least something like that, we are looking at one side of a normal distribution curve. So this will be a one-tail problem. So the first part of any hypothesis testing, the first step would be to define. So this is solution to define your hypothesis. So in this case, the president is claiming at least 160. So your null hypothesis, and this is kind of what is based on previous all the data you are getting your population mean, which is this is greater than or equal to 160. So at least means greater than or equal to. So at least is greater than or equal to a certain value. So that is okay. Let me greater than or equal to. So alternative would be mu less than 160. So this is, you kind of think that it is less than 160, and that's the reason why you are doing the study. So to justify or to see whether the president's claim is true or not, you will collect the data from the university and evaluate it. So so all this data will be given. So this will be given in your problem. So you collect your sample size, you take 16 students and you obtain their, you will measure their weights and you will obtain the sample mean of 163, and then sample standard deviation is 5 and your significance level alpha is 0.05. So as you know, n is 16, so this is less than 30 and s is given, so sigma is unknown. So you will be using t-statistic based on these two. So now the second step of so this everything is given. So the second step of hypothesis testing is to compare test statistic with critical value. So as we determined that we will be using t statistic, so our test statistic the formula for t is x bar minus mu s over root n. So this will be x bar is 163 minus mu would be, our mean is given as 160, population mean. So and then your sample standard deviation is 5 over the sample size is 16. So this is going to give you 2.4. So now we have to determine what would be a critical value. So this is a one-tail problem. So we are looking for, because this is greater than or equal to, you are looking at one side of the curve. So we will see how this looks in a normal distribution curve. So the first thing I will do is I will draw a normal distribution curve, and this curve represents precedence claims. So the mu is 160, and then our z, not z, this is, we are using t. So anything above certain t value, right? So if you see our hypothesis mu greater than 160, so anything above certain value, this whole region, the precedent is right. So that means we do not reject H null. So when we don't reject an H null, that means the precedent is right. So anything here to the left of this point is reject H null. So this is where the precedence claim is not true. So that is how it looks. So we are interested in determining what this point is. So we know this would be this is a negative side of a curve, so this would be something like negative t alpha. No, so this let me show you. So they gave us alpha as 0.05. So this area is 0.05, and this whole area would be 0.95. So I will write it here. So this area will be 0.95. So in this area, this 0.95 area, we do not reject H null. That means precedence claim is true. And then this 0.05 area, we will reject H null. That means precedence claim is wrong. So this is why we are directly using alpha. If it is two tail, we will be using alpha by 2 on both sides. So the formula here for critical value, so this is critical value, the formula will be T alpha degree of freedom. So this is again T alpha degree of freedom is n minus 1. That is what we are looking for. So our alpha is 0.05. So T 0.05 and n minus 1, our sample size is given as 16. So we will do 16 minus 1. So we are looking for T 0.05 16 minus 1 is 15, so this value is what we are looking for in our t table. So I will go to that, will go be giving me this value. So I will go to our what's that, our canvas, and download t table. So again, this is, I will go to modules in our campus and go to module 0, look for calculation aids, and then download statistical tables. Do enable editing, and now I'm going to t table. So I'm currently in Poisson table, so I will go to t. So I have t, so I'm looking for t t 0.05 and 15. So I will go here, look for t 0.05, so that is this one, and 15 is the degree of freedom, so the value would be 1.7531. 1.7531. So this is 1.7531. So this point is going to be, so this is always, you remember t, this value t table usually gives us right of the curve. So usually t table which we looked, it's going to give us t 0.05 and 15 here is 1.7531. So because we wanted the other side of the curve, this will be negative 1.7531. So that is our this point. So now we go and look for test statistic value and see where does that lie. So I will go and look at, this is 2.4, and then I have negative 1.7531. 2.4 will lie on the right side of this negative 1.7531 in a number line. So this is 2.4, and clearly it's falling under do not reject region. So do not reject H null. So our claim will be there is sufficient. So when I say do not reject H null, what it means is this claim is true, which is the president's claim. So the president's claim is true. So that means there is sufficient evidence that the weight of students in the university is at least 160. So this makes president's claim true. So I will use that's the conclusion of the t statistic using one tail. Now I will do the same problem using our calculation aids. So I will note down all the things that are given in the problem, including your hypothesis. So this is calculation 8. So our hypothesis, if you look at it, this is our, so I'm going to note down all this. So our hypothesis is mu greater than or equal to 160. That's our null hypothesis. H null is mu greater than or equal to 160. Alternative would be mu less than 160. And then these are given values. Our sample size was n is 16, and then x bar is 163. Our sample standard deviation is 5, and then our significance level is 0.05. So I will note down these values, and now I can download our calculation aid and solve this. So I will go to our, again I'm going to modules, module 0, calculation aids. Okay, I went to a wrong tab. So calculation aids, and then chapter 10. I will download this Excel worksheet, and then I will do enable editing. I am in proportion test. I wanted, so this problem, if you see, S is given, that means sigma is unknown. So this is unknown standard deviation or variance, and then n is less than 30. So I will be using unknown variance sheet in this. So let me write it here. I will be using unknown variance sheet. So I will go here and then do unknown variance. So mean test unknown variance, that is the sheet I am using. Now which case to use? Now this says alternative HA, alternative mu is greater than and mu is less than. So I will go to our Word document, and alternative I am looking at. So I am looking at this, and mu is less than is what our alternative is. So I will be using this sheet, or this case, mu less than. So the population, okay, let me. So the population mean is, I think it's 160. So I will be putting this one, 160 population mean. So this is 160. Sample mean is, I think it's 163. Let me check. So this is 163. And then sample standard deviation is 5. and then alpha significance level, alpha is given as 0.05. And then sample size, I think it is 16. Let me cross check again. Sample size is 16. So if you see, we have test statistic value 2.4, critical value minus 1.753, and don't reject. These are the same things we got. So that's how you will be solving these one-tail problems. So I will now go and see if I can solve a Hawk's learning problem. So let me log in. Okay, so this is a Tstat problem. So this is a carpenter is making doors that are 2058 millimeters tall. So this is the because it refers to all the population. This is your population mean. If the doors are too long, they must be trimmed, and if they are too short, they cannot be used. So a sample of 15 doors is made, and it is found that they have a mean of 2048 millimeters with variance 676. So is there evidence at the 0.025 level that the doors are too short and unusable? So when they are saying the doors are too short and unusable, so they are referring to only one side of the curve, of the normal distribution curve. So we will be kind of having a one tail problem. So the first thing is, let's write the hypothesis for this problem. So this is Hawk's problem, and the mean, let's look at what mean is given. Mean is given as mu 2058. So our H null and H alternative. So if they are too short, we can't use them. So that means if it is too short, that is our alternatives. So because anyways the company wants to use them, so if it is long, they can kind of trim and use it. So the carpenter, if it is 2058 or more, they are good. So that will be our null hypothesis, and alternative would be if it is less, then we can't use them. So our our null hypothesis is greater than or equal to 2058. So less than, we cannot use it, and then null is it can be 2058 or more. So if it is more, we can trim it and make it 2058. So that's how you will be having your hypothesis. And let's look at what other things they gave. So a sample of 15 doors is made. So let's, our sample size is 15. So n is, so this is all given, n is 15, and then and it is found that they have a mean of 20548. So mean is 2048, so x bar is 2048, and then with a variance of 676. So they gave us variance instead of standard deviation. So they gave us s square, which is variance 676. So you want s. So what do? You do a square root of 676 to get the standard deviation. So let me see what is the square root of 676. So this is 26, and then they gave us a significance level of, okay, I went into a wrong sheet. They gave us a significance level of 0.025. So all this is given. So the current question is asking us to type in this. So if you see the current question in Hawk's Learning, it is asking us to type in these hypotheses. So our hypothesis is mu greater than or equal to 2058 is our null hypothesis. So I will type that. So I will go to keypad, type mu, and then greater than or equal to, then 2058. So if that is, alternative would be less than. So again I am going to type mu less than 2058. So that would be our hypothesis, and I will submit it. So if they ask the other values, you have to just key in. I think this is only a one-step question, so I will just try to solve this and give you, show you the answers in our calculation aids. So let's go and download our calculation aid. So I will close this one which we used previously, and then download a new sheet. So chapter 10. Again, which spreadsheet to use. Currently I'm in proportion test. So if you go to our question and look, our sample size is n less than 30 and s is given, so sigma is unknown, so you will be using unknown variance sheet. So this is Tstat. So unknown variance sheet means we are using Tstat. So I will go to Tstat and look for type in those values. So now we go to unknown variance, which is Tstat, and then which case to use, case 1 or case 2 or case 3. We know this is a one tail problem, so you will look for what is your alternative hypothesis, mu less than. So I will go and look for which case has mu less than H alternative. So this one has alternative mu less than, so I will type in the values there. So this is mu less than, our mean, population mean is 2058, so I will go and type in 2058 here. So this is 2058, and then the sample mean. The sample mean is 2048. I will do 2048, and then sample standard deviation is 26, and then alpha is, I think it is 0.025, alpha 0.025, and the sample size is, let me see what is the sample size. Sample size is 15. So this is 15. So this gives us the test statistic value negative 2.49, and the critical value is negative 2.14, and don't reject null hypothesis. So when I say don't reject, this one is true. So there is sufficient evidence to claim, actually there is insufficient evidence to claim that the doors are small or too short. So there is sufficient evidence that the doors have larger size larger size or 2058. So that is the claim which we make. So this concludes my lecture on T statistic, and thank you.